All right. So since I had a coughing fit, let's start here. There are 3 cranial nerves that carry information from different regions of your tongue and throat, actually, and they all terminate in this area here called the taste area, okay, or the taste cortex. So you have basically in red, okay, the front of the tongue is being carried by this nerve here, which is the trigeminal nerve, okay? Kind of the back of the tongue here in white with this green nerve here. The green nerve here is going to be the glossopharyngeal. Then the back of the throat, well, I guess the top of the throat, back of the tongue, this purple nerve right here is going to be the vagus nerve. Now, while all of these are different nerves, where they synapse, where they meet up, actually carries that information up to that same taste area. Okay. So, switching gears, we went from the sense of smell to the sense of taste. Now we're moving on to the visual system, okay, or the sense of sight. So, the visual system. Visual input is actually very important to learning. We tend to, as a species, observe and then mimic behavior. If you've ever watched kids with their parents, they mimic their behavior. They start using utensils because they see their parents using utensils. The visual system gives us the ability to differentiate between light and dark, color and hue, and it gives us the perspective of distance. So light and dark, you know the difference between a light room and a dark room. You also know the difference between colors, between blue and red and, I don't know, yellow. But when it comes to hue, we're talking about like a royal blue versus a navy blue versus a sky blue. That would be, they're all technically the same color, but they're different hues of that color. Distance, of course, is the ability to tell how far something is away from your body. Now, the eye itself, when we're talking about the eye, you've got the eyeball, and then internally you have a floating structure. Well, it's not actually floating, but it's a structure internally called the lens. Your eye responds to light, and it begins afferent action potentials. Afferent means arriving. Okay, so it's going from your eye, okay, up to your brain. It's arriving at your brain. So the eye has the sensory receptors. They travel up through the optic nerve. Then that becomes the optic tract. And then in the brain, they're going to the visual cortex. Okay, the visual cortex is what gives you color and shape and pattern. The accessory structures, things that aren't your eye but are important to your eye, are there to basically protect from direct sunlight and from damaging particles. The reasons that we have eyelids, or the reason that we have eyelids, is because it helps to kind of reverse squeegee our tears on the surface of our eye. And if something is heading to our eyes blink and the eyelids prevent things from getting into your eye. Now, optic. We've got optic nerves. We've got optic tracts. We've got optic pathways. Optic is referring to that visual system. So let's talk accessory structures first. They're there to protect, to lubricate, to move, and to aid in eye function. So we've got the eyebrows, eyebrow. We've got eyelids and eyelashes. We've got the conjunctiva. We've got the lacrimal apparatus. and we've got the extrinsic eye muscles. In other words, they're not inside the eye, they're outside the eye. So let's start with the eyebrows. The eyebrows actually prevent dripping sweat from getting into your eye. It's kind of a catch. It also helps to shade your eye from direct sunlight. If you take the palm of your hand and you put it flat up against your face, right where your eye is, you will notice that the ocular, the bone of your eye, sits in front of your eyeball. And right at the top of that ocular is where your eyebrow is. If somebody throws glitter in your face, the first thing you do is you kind of look down. Yeah, you'll close your eyes, but you still kind of shift your head down. One of the reasons that we do that is because that protrusion of the orbital of your eye actually means that that glitter won't go up and in. Gravity pulls it down and away. And if any does happen to get close to your eye, the hope is that the eyebrow will catch it. Now, shading from direct sunlight. Anybody who's ever played football or watched football, you know how the guys put that big black gunk under their eye? The reason that they do that is because it helps prevent sunlight from reflecting off of their skin and getting into their eyes. So your eyebrow is just kind of a natural extension of that. Instead of having to put goop everywhere, you actually have something that just naturally occurs. And it should be there. I know that women have a tendency to want to, do the Sharpie eyebrow. Yeah, no, don't do the Sharpie eyebrow. You need to actually have something there to catch things so that they don't get in your eye. It's protective. Now, the eyelid with associated lashes. You can be real fancy and actually call the eyelid the palpebral if you want to. They also help to protect the eye from foreign objects. You close your eyes when things fly at your face. The palpebral fissure is actually the space that exists between the two lids, and that fissure only exists when your eyes are open. If your eyes are closed, the fissure doesn't exist. The canthi, which is plural, by the way, canthus is singular, canthi is plural, is the corners where the eyelids meet. So you've got the medial canthus and you've got the lateral canthus. Remember, medial means toward the middle, lateral means toward the outside. These are the directional terms you should have learned in AP1. Then you've got the caruncle. That's this pink thing in the middle of your eye here. Okay? You can see the pointer pointing to it. Okay? It's a pinkish mound in the medial canthus, and it actually houses modified sebaceous and sweat glands. So don't forget, sebaceous glands are the oil glands. Okay? Whoops. And sweat glands. So your eyes tear up every second of every day, which means that if you don't have a barrier that can kind of hold that liquid in there, you'd be crying all day long. So having kind of a light sheen of oil here basically keeps your tears in your eye. The sweat can actually be used to lubricate your eyelashes. So your eyelashes are also kind of like your eyebrows, there to catch things. Anybody who's ever had a cat knows that feeling of, oh, I've got cat fur. And you'll find it on your eyelashes, not normally in your eye, because your eyelashes have caught them. The conjunctiva. The conjunctiva is a thin, transparent mucous membrane on the inner surface of your eyelid, and the fold that connects to the sclera. So let me get a better color. Let's do blue. This right here, that comes around is going to be the conjunctiva. Conjunctivitis, pink eye, is when this actually gets infected. Okay? Sorry. Sorry. Okay. So, if you peel your eyelid back, if you pull your eyelid down, that pink mucousy looking surface is actually the conjunctiva. The lacrimal apparatus. The lacrimal apparatus is this thing in the second picture down here. So you've got the lacrimal gland. The lacrimal gland is the thing that produces the tears that help to coat your eye. Okay? Sorry, I had to take a sip of my drink. No. Okay, there. The lacrimal gland has these ducts here. You can see them right next to the eyelashes. There are these tubes. Don't forget, duct is just a fancy way of saying tube. So this is producing tears. This lacrimal gland is producing tears. And then these ducts, these tubes, are carrying it down to the surface of the eye. Dun, 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 dun. There we go. So you've got this lacrimal gland, you've got these ducts, and they're putting this on the surface of the eye. And they pass over the surface of the eye. Then you've got kind of two drainage points here at the caruncle. The lacrimal canaliculi. Look at the first 5 letters. It spells canal, right? Wow, I completely misspelled that, didn't I? Okay, so the canaliculi are the drainage points for your tears. Your tears are being produced all day long, 24/7. If you don't have a way to drain them out of your eye, you'd be crying all day long. So you've got these two lacrimal canaliculi that drain into the lacrimal sac, that eventually drain into the nasolacrimal duct. So you know how when you're really crying a lot, your nose starts to run? The reason that that's happening is because you're overflowing the system. Normally, as your eyes drain, it's not a lot of fluid. It's not a ton of fluid. So you don't even notice that it's there. But when you cry and you're overproducing that fluid, it actually causes kind of an overflow. So your nose starts to run. The extrinsic eye muscles. Extrinsic. Exit. Think outside. Their job, their function is to move your eyeball. Okay? So when you look up, when you look down, when you look sideways, either laterally or medially, when you rotate your eye, these are all extrinsic eye muscles. And you have 2 different kinds. You've got the rectus muscle and you've got the oblique muscle. From AP1, you should know that rectus means straight. Okay? So rectus muscles are connected and they go straight back and connect to bone. Okay? And with rectus muscles, it's pretty easy to understand what their function is, because if it is an inferior rectus, it moves your eye down. If it's superior, it moves your eye up. If it's medial, it moves your eye in towards your nose. If it's lateral, it moves your eye out to your shoulder. Because they are straight muscles, because the fibers are all in the same direction, they pretty much just move in one direction. Oblique muscles are a little bit more tricky, and the reason is because the oblique muscles wrap around the eye. You can actually see this muscle here is the superior oblique, and this muscle down here at the bottom is the inferior oblique. they're responsible for a lot of the moving of the eye, rotationally. We'll just go with it makes your eye rotate. So the superior oblique actually goes the opposite direction of what you would think. So let me see. Here's your eye. Okay. The superior oblique muscle, here's your nose, here are your lips, okay, actually rotates your eye medial and down, okay, so this direction. Whereas the inferior oblique goes medial and up. Okay, so you would think that with the names inferior and superior, it would go the opposite direction. But if you look at where the inferior is and you're pulling on it, it makes sense that it would cause the rotation to go up. When a doctor is worried that one of these muscles is not working correctly, when a doctor is concerned that it doesn't seem like your eyes are moving the way that they should, they will perform a really simple test called an H test. And basically what they say is, I want you to make the shape of a capital letter H with your eye. If you can do that, if your eyes can go, up, down, side, up, down, then they don't really worry about it. But if you can't make that pattern, depending on where it is that you're having problem with the pattern, it can actually indicate exactly which muscle is having problems. A lot of times when we're going through this in class, people will ask about a lazy eye. What is that? Well, with our rectus muscles, okay, we've got one at the top, one in the middle, one lateral, and one underneath. They all should have about the same amount of tension on them, meaning that they center your eye so that your eye is in one specific spot. But every now and again, one of these muscles will become weak. And when that muscle becomes weak, all of the others still have the same strength. So the other muscles will start to pull in a different direction because that weaker muscle can't kind of pull back and keep the eye where it's supposed to be. When that happens, if you can't fix it by exercising the eye, they will actually take a little chunk of this muscle out and then they'll sew the other pieces back together just to increase the tension enough to keep the eye where it's supposed to be. So, looking at the anatomy of the eyeball, okay, you actually have 3 layers to the eyeball. You've got the fibrous layer, the vascular layer, and the retina. Okay? Think of an M&M, a peanut M&M for me. Okay? So you've got the peanut, you've got, let's say, the skin of the peanut, you've got the chocolate, and you've got the candy. So we've got the candy, the chocolate, and the peanut in the middle. And every now and again, you get the skin of the peanut. Okay? Your eye is kind of like a peanut M&M without the peanut in the middle. Okay? So you've got the fibrous layer. Whoops. Okay, you've got the fibrous layer. The fibrous layer is equivalent to the candy, that hard candy shell out here. Okay, So this is the fibrous layer right here. The fibrous layer is the outermost layer. It is consisting of the sclera, which is the white of your eye, and the cornea. The cornea is very much in the front of your eye. Okay, this is where what you can see through to see the iris, the color of somebody's eye. The vascular layer. The vascular layer is going to be the chocolate. Okay, so the vascular layer is the next layer inward, and you can see it right here. This is the vascular layer. Okay, in the back, where the vascular layer is in the back here. Wow, that's terrible. Try and be a little more careful. You've got something called the choroid. Okay, but as this vascular layer works its way forward, you'll notice that it gets this kind of lumpy, bumpy area here. That's actually called the ciliary body. Then, as we come even further forward, hang on, give me 1 second. Let me see if the laser pointer will work if I do this. Or not. You'll notice the iris. This eye is actually blue. So I can't zoom in if I've got that. Good to know. Or I can't zoom in at all anymore. What the heck is that about? Oh my goodness. Nope. All I did was highlight, which isn't helpful. This iris that you see, I'm going to kind of color it in yellow. That is still part of this vascular layer here. It's just kind of the most forward or front-facing part. Finally, internally, we have the retina. This layer here that you see, the most inner portion, is going to be the retina. In our peanut M&M, this is the skin of the peanut. Okay, so the skin of the peanut is the retina. Now, why did I say without the peanut? Because internally, inside of your eye here, it's all fluid. There is nothing solid in there that actually holds things in place. So you've got kind of these empty chambers in your eye. And then the last thing is this kind of floaty thing here. This is the lens. Okay? So let's start with the fibrous layer of the eye. This is the outermost layer. Okay? You have anatomically, hang on, let me get my pen and a good color. Okay, anatomically, this is made out of dense collagenous connective tissue and elastic fibers. The sclera of your eye is actually pretty durable. It's one of the most durable things that I've ever dissected. You have to be very, very careful when you're dissecting an eye, because if you squeeze too hard, it's full of fluid. It'll kind of squirt on you if you're not careful. So why? Well, think about it for a second. This is the part of your eye that is exposed to the environment. It needs to be able to take quite a bit of beating so that it doesn't get damaged really easily. If it did, we would all go blind fairly quickly. So physiologically, what does the sclera do? Well, one, it helps to maintain our eye's shape. It is stable enough that when you put pressure internally, when you fill it with fluid, it actually will maintain the eye's shape. It's not like it's going to explode. Two, And this has to do with the fact that you've got dense collagenous connective tissue and elastic fibers. It protects the inner eye structures. It's actually going to protect what's inside your eye. 3, it's an attachment point for the muscles. Remember our superior, inferior, medial, and lateral rectus, and our superior oblique and our inferior oblique? If we want to be able to move that eye around, we have to have a pulling point to do that. One half of that muscle is attached to bone at your skull, that's true, but the other part of the muscle, the other end of that muscle, is attached to the sclera. Again, in the front here, you've got the cornea, okay? The cornea, anatomically, it is basically like a glass window in the front of your eye. The outer surface, the one that's actually exposed to the environment, this outer surface here is actually stratified squamous epithelium. Remember, stratified means more than one layer. Squamous means squished cells that kind of look like a flat pancake, but you've got multiple layers of cells in the front. In AP1, one of the first things that we said when we talked about stratified, if anything is stratified, there's always going to be a protective function. So this is protective. This is going to protect the front of your eye. The inner surface, however, the inside of that eye, is actually simple squamous epithelium. Simple means one layer of cells. Squamous still means squished cells. They look like pancakes. Internally, I shouldn't have to have multiple layers of cells, though. There shouldn't be anything inside of my eye that's trying to abrade the inside of my eye. Physiologically, function. What's the function of the cornea? It allows light into your eye. The whole reason that it's clear is so that light can get into your eye and cause your photoreceptors to respond. Photo means light. Okay, so photoreceptors are light receptors. Also, cornea, some kind of interesting things about the cornea. Cornea is one of the most durable parts of the body. You can damage a cornea and usually it will heal. Is there a limit? Of course there is. Also, because the cornea doesn't have a direct blood supply, it's one of the only organs in the human body that you can transplant without doing any type of tissue testing. The histocompatibility of the cornea doesn't have to be tested. Nobody will reject it because it doesn't have a direct blood supply. Okay, so let's talk about the middle layer, the vascular layer. You've got the choroid. The choroid is what you have that is extremely smooth on the back of the eye. So if you look back here, there's kind of this pinky red layer between the white of the eye and the yellow. See that kind of pink line right there that the arrows are pointing to? That's the choroid, okay? It's in the back of the eye, and the reason we call it the vascular layer is because it is highly vascular, okay? It's got a lot of arteries and veins in it. There are also a whole ton of melanocytes in it. Remember, melanocytes are the ones that create the color. The back of your eye, for all intents and purposes, is black. It's jet black because we want light to go in once and then not bounce around. Black absorbs all of the wavelengths of light. So once it hits and it gets absorbed by the black, it can't bounce around anymore. So what that means is it helps prevent light scatter. It is one shot. It goes in, it hits your retina, and you're done. Our eyes work this way because we are diurnal, meaning that we are awake and active during the day when there's plenty of sunlight. Animals actually have something on the back of their eye called the tapetum lucidum. The tapetum lucidum kind of resembles the inside of an oyster. It's kind of iridescent. And for nocturnal animals, that's actually pretty important because how much light is there at night? Not much. So having a way to kind of bounce that light around on the inside of their eye to create better signal works for them. For us, not so much. Now, as we come back around toward the front of the eye, okay, as this comes back around toward the front of the eye. Here's that kind of bumpy, lumpy thing that I was describing earlier. So here it is in this picture here. Okay. This is the ciliary body. Okay. Number 2. It is actually between the choroid up here and the iris up here. It's this little area in the middle. It produces the fluid that's actually in the front of your eye, the aqueous humor. Aqueous humor has a consistency like water, like just regular plain old out of the tap water. It attaches to the lens, which you can see here. You can see these little strings attaching to the lens from this lumpy, bumpy thing up here. When I'm looking at this, I'm seeing a little hand. So I hope you're seeing a little hand too. I'm hoping. So this ciliary body is actually made out of smooth muscle, and it is attached, like I said, through these suspensory ligaments to the lens. When you contract those ciliary muscles, or you relax those ciliary muscles, it actually changes the shape of that lens. And by changing the shape of the lens, you change how light scatters once it hits that lens. Okay? So you can spread light out in the back of your eye, or you can focus it into a single point just based on the shape of the lens. Now, in front here, you can actually see it kind of hanging out over the lens here, is the iris. Okay? The iris is the colored portion of your eye. It actually has 2 separate rings of muscles. It's got an inner ring that kind of looks like a drawstring for a trash bag. And then it's got this outer ring that kind of looks like the radiating picture of a sun that a kid can draw. Okay? So why? Well, these 2 sets of muscles do 2 different things. You've got the sphincter pupillae, which basically is circular, and it reduces pupil size. There should be an R here. It makes your pupil get smaller. One of the coolest things, because your teacher is this nerdy, that I used to do when I was in grade school, we would go from outside on the playground where, the South Texas sun was shining, into a building that had like 25 watt bulbs. So as people would walk into the hallway, I would stare at their eyes because I wanted to see their pupils go from really, really small to really, really big. That is actually caused by the dilator pupillae. Okay, that set of muscles that looks like the sun out here is that dilator pupillae. And when they would come inside after being outside, it was those muscles that would pull out to make the hole in the eye bigger so that you got more light in your eyes so that you could see. If you want to do an experiment, a really cool experiment to do, use your flashlight on your phone. Take somebody into a dark room and use that flashlight, go over their eye, and you'll see their pupil get really, really small because all of a sudden there's a bright light in their eye, which I think is the coolest thing ever. But, that's me and I'm weird.